I will be very angry with all of you. Right. So this is the definition of electric charge. Very, very important. All right. So now here you see, if there is a metal rod, and if you connect a battery like this, you can see here from the negative terminal of the battery, electron current is going, and it will go to the positive terminal. And the conventional current is opposite to the flow of electricity. Right. And then if this is a glass rod, the bulb is not glowing. Okay, that clearly shows in metal rod, electric current can flow. In glass rod, electric current cannot flow. So those materials in which current can flow, we call it as conductors. Those in which current cannot flow, we call it as insulators. And that means now in conductors, what is there in conductors? What is there in conductors? That boy is correct. Free electrons or ions or both. And what are these called? Free electrons, ions? Charge carriers. They carry charge. So simple answer is insulators don't have charged carriers. Conductors have got charged carriers. And if it is metals, it has free electrons. If it is salt solution, it has got ions. Got it? Now here you see, if it is pure distilled water, the bulb is off. It's a bad conductor of electricity. You put salt in that, it becomes a good conductor of electricity. And inside the chemical cell, there is a chemical reaction. Sodium and chlorine ions are formed, and these ions will act like charge carriers. Okay, clear? Any questions here? Now don't ask me about the chemical reaction. That in electrochemistry I will teach you. Right? Okay. So now conventional current, see, if positive charges are going in this direction, the conventional current is in this direction. If the negative charges, so the total current will be in this direction. Okay, anyway, I have got one more slide where I will make it clear. See, here, what I am trying to show, the positive charges are going like this, conventional current is like this. Negative charges are going like this, conventional current is like this. So now, some negative charges going like this, some positive charges going like this. So, the total conventional current will be in this direction. Okay? Now, we will come to the basic term. Okay? What is electric current? Carefully. Electric current is defined as the net rate of flow of electric charge. Charged particles such as electrons or ions moving through electrical conductor or space through a surface. Now every word can be converted into many MCQs. So every word very carefully. Electric current, see the word electric current. There are many current, water current. Anything that flows, we call it as current. So here specifically electric current. Net rate of flow. What do you mean by net rate of flow? See, on dabba they will write gross weight, net weight. Have you seen? What is gross weight and net weight? Gross means, see, now you have got Horlicks in a bottle. So the total weight of the bottle is, say, 1,100 grams. Net weight of Horlicks is 1 kg. That means total weight minus the weight of the glass and the lid gives you net weight. Got it? Hanga idraga net flow of electric charge. Net flow of electric charge andre you know, there are 10 positive charges going in this direction at a particular instant of time. Hello? Yes, sir. There are 10 positive charges going like this. So the current will entirely be due to 10 positive charges. 10 negative charges are also simultaneously going in that direction. Then the current due to 10 negative charges will be in this direction. Current due to 10 positive charges will be in this direction. So if you add these two conventional currents, what is the net current? 0. Got it? So what is the net flow of charge? 10 positive charges like this. Okay? 10 negative charges like this. What is the net flow of charge? 0. 10 positive charges are going like this. 10 negative charges are going like this. What is the net flow? Right?
Some positive charges.
10 positive charges going like this, 10 negative charges going like this. What is the net flow? 20. Why 20?
Because the
Conventional current due to this is in this direction, conventional current due to this is also in this direction. So the net charges flowing here will be 20. Net charge, total charges. Understand? See, there is a difference. You see here, please understand. We are taking the algebraic sum of the conventional current. 10 positive charges will have some conventional current. 10 negative charges will have some conventional current. 10 positive charges, what is the conventional current? In this direction. 10 negative charges, what is the conventional current? This direction. Add the conventional currents, you will get the net conventional current. Got it? See now, if I take this duster, how many positive charges are there? Some. How many negative charges are there? Equal. Thank you. So now you see this duster is going. So look at the charges. How many positive charges are going in this direction? Same amount of negative charges are also going in this direction. So current due to positive charges is in this direction due to this duster. Current due to the negative charges are in this direction. Conventional current. So the net current if the duster is going like this is 0. So a duster is moving, though charges are moving, current is not there. Got it now? Understood? That is what I have written. The electric current defines the net rate of flow of electric charge. I suppose you understood net rate of flow. Understood or not? I will teach you once again. Understood? Nodri, ನೀವು ಮನಸ್ಸಿಗೆ ಒತ್ತಡ ಕೊಡಬೇಕು. ಒತ್ತಡ ಕೊಡಬೇಕು. You should apply your mind. It is something like lifting weight. You have to put pressure on yourself. If you don't understand, you should ask. Now, see in this, how many positive charges are there? Some. How many negative charges? So now this, through this area, this duster has gone. So how many positive charges went like this? Some. So what are the current due to positive charges? Like this. What is the current due to negative charges?
In
the same direction. Correct? Opposite direction. So if you add these two conventional currents, so the net current is 0. Net rate of flow of charge is 0. Net flow of charges is 0. Got it? Now if you divide the total number of charges divided by the total time taken. See here. Now if you take this point, okay, can you see this point, this surface? See, this started entering. How much time it took for this many charges to cross this point? How much time did it take? Physics see, if you can measure, you should say 1 second. How is it 1 second? You should see students, when you know that there is something that can be measured, but you are not able to measure, then you should simply give some variable name to that. See, you say no, oh, there is a person. Who is he? You don't know his name. That doesn't mean he doesn't have name. So what will you do? You will say, call them as X person. That is how you do sums, no? That's how you do, no?
Yes.
That's how you should do. So, how much time did it take to cross? Some time t or delta t. See, use the word delta. Delta means delta t. Delta means interval of time. See, now interval, understand students. Now the moment this enters here, you mark the instant of time t1. And then the moment this leaves, mark the instant of time t2. Stopwatch t1, t2. T2 minus t1 gives you interval of time. Understand? So now so many charges divided by delta t gives you time rate of flow of net charge, or that is what we call it as net rate of flow of electric charge. ತಿಳಿದ ನೋಡ್ರಿ, ಇದ್ರ ಮೇಲೆ ನಾನು 10 ಕ್ವಶನ್ ಕೇಳಬಹುದು. ನೀವು 10 MCQ ಕೇಳಬಹುದು. ಬರೀ ಏನ ನೆಟ್ ಫ್ಲೋ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್. ಅರ್ಥ ಆದ? ನೀವು ಹಿಂಗೆ ಕಲಿಬೇಕ್ರಿ, ಹಿಂಗೆ ಜೀಪಾಗಿ ಕಲಿಬೇಕು. ಆ್ಯಂಡ್ ಇದನ್ನ ಮನದು ಕೊಟ್ಟು ಖುಷಿಲೇ ಕಲಿಬೇಕು. ಇದನ್ನೊಂದು ಇನ್ಫಾರ್ಮೇಶನ್ ಥರ ತಲೆಗೆ ಹಾಕೊಟ್ರೆ ನಾಳೆ ಕೇಳಿದ್ರೆ ಎಲ್ಲೇ ಕೇಳೇನಿ ಅಂತ ತಲೆಯತ್ತೀರಿ. ನೀವು ಇದನ್ನ ಇನ್ನೂ 4 ವರ್ಷ ನೆನ್ಪಿಟ್ಕೋಬೇಕು ಮಿನಿಮಮ್. ಅರ್ಥ ಅದಲ್ಲ? ನೀವು ಇಂಜಿನಿಯರಿಂಗ್ ಪಾಸ್ ಆಗುವವರೆಗೂ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. ಇವೆಲ್ಲ ಬೇಸಿಕ್ಸು, ಫಂಡಮೆಂಟಲ್ಸ್. So you have to put pressure on yourself, and totally 24/7 you should immerse yourself in science. Nothing else. Don't see that this movie, don't see that this and all, don't talk that and this, because the moment you talk something, you see something stupid, there is a hole created, and all that you have worked to build knowledge will go. Like how you puncture a puga balloon, all the air will go, like that it will go. So don't get distracted and start loving science. ಹೋಗ್ಲಿಪ್ಪ ಅದು ತಗೊಂಡು ಏನು ಮಾಡ್ತೀವಿ ಹಂಗೆ ನಾಕೋಬೇಡ. ಇಫ್ ಯು ವಾಂಟ್ ಟು ಪರ್ಸ್ಯೂ ಸೈನ್ಸ್, ಯು ಬೆಟರ್ ಲವ್ ಸೈನ್ಸ್, ಅದರ್ವೈಸ್ ಲೀವ್ ಇಟ್. Electric current is defined as the net rate of flow of electric charge or charged particles such as electrons or ions moving through electric conductor or space. Now understand, in the tube light that you see, the charged particles are moving from this end to that end. There is no the charges are flowing in the space between the two electrodes. There is nothing solid in between. Still it can flow. Understood? And so we can measure how many net rate of flow of charge from this electrode of the tube light to that electrode of the tube light. This is what is this one. It need not be conductor, it can be space also. But that doesn't mean now in air you will charge bitre it move ಆಗ್ತಿtle do. It can move, but there is certain condition required. If there is electric field here, what did I say? Electric field in this direction. Now if I keep a positive charge here, this will accelerate in this direction. Understood all of you? If there is electric field here, and if you keep a positive charge here, it will accelerate in this direction. So in the tube light, there is electric field created. And therefore, the charges are moving in space. Now you understand. Even in a conductor, the current will flow. Why will the current flow? One is they have got charge conductor. In a conductor, this is a conductor, correct? There are three electrons. They are in random motion. Random motion ಅಂದ್ರೆ say one electron is going like this, another is coming like this, some like this. Random. ಈಗ in Durgad Bail, people will be moving in random in marketplace. Some are coming like this, some are going like this. Hello, are you all with me?
Yes, sir.
So if you see net rate of flow and random is moving, it is 0. Because जितना इस तरफ जा रहा है उतना ही इस तरफ जा रहा है. So in random motion, the net flow is 0. In disciplined motion only there is net flow. Understand? See, now in your school they leave you on the ground, free for all. So Srinath is going towards somebody, this fellow is going to somebody, that fellow is going to somebody. You will all be going. What is the net? 0. Supposing now you are all distributed, then your headmaster comes and says, "Hello, come." Then all of you will come towards your headmaster in this direction. Then there is net flow. Otherwise, it is random. Random motion. How many students are coming towards this side in random? How many are coming towards this side? That much are going that side. So the net flow is 0 in random motion. Got it? So there are free electrons in random motion inside a conductor. So what is the current in a conductor?
0.
Louder.
Net flow is 0.
Net flow is 0. So the current is 0. Good. Understood? Hinga concepts will go. Now if I connect this conductor to a battery, then conventional current will start flowing like this. Hello?
Yes, sir.
Electrons will start moving in this direction. Correct?
Yes, sir.
Now there is net flow. Now why did the free electrons in the conductor move?
They came in a proper direction.
Why did it move? Madala conductor sumna ita, there was no net flow. Now why there is net flow? Pardon?
The positive
Electric field created.
That is that. See, this girl is sitting quietly and learning. Just now I told. See, this is how you should correlate. Why did the charges move in the tube light? So that is the basic reason why charges will flow. See, there should be some cause. No. See, you are all living. One of the reasons why you are living is because you are breathing, and because there is oxygen in the atmosphere. Otherwise, halki barisಬೇಕು. ಹೌದಿಲ್ಲ? Common sense. Oh no, common sense with science will make you powerful. So the moment you connect a battery, this battery will create an electric field in this direction. This battery will create electric field in this direction, and therefore the electric current will flow. Right? The electric field is in this direction. For negative charges, it will go in this direction. Positive charges, it will go like this.
electric field means conventional current direction.
Conventional current direction. Understand. See, here the conventional current is flowing in the direction of electric field. But it is not a generalization. It is not a generalization, understood? Sir, conventional flow direction is electric field. Hangala. In many cases, that is not the truth. Understand? That is not the truth. Okay, please understand that. Right. So, electric field is the reason. So, the moment you connect battery, there is electric field set up, therefore it will move. Okay? So, therefore, such as electron moving through the electric current cross space through a surface. I suppose you understood. Nodi, this definition is powerful. Nim school book naga one sentence kotara. Adana 1 second ola kaltu bitra kaltangalla. Neeving ಆಳವಾಗಿ deep ಆಗಿ ಹಿಂಗೆ experimentally ಕಲಿಬೇಕು. Then you know any question asked in this you can answer. Otherwise, even the simplest of the question you will goof and come in the examination, and all your examination questions will be with negative marking. Remember, right answer +3, wrong answer -1 or -2. Understood? So be careful. Then this is definition of electric current. All the definitions of physical quantities and concepts, they have two parts. One is qualitative. ಇದೆಲ್ಲ ಕೊಡ್ತೇನೋ ರಾಜಾ, ನಿಮಗೆ ವಿಡಿಯೋ ಮಾಡ್ಕೊಡಕತ್ತೀನಿ. ಆ ವಿಡಿಯೋ ಪಾಸ್ ಮಾಡಿ ಅದರ ನೋಟ್ಸ್ ಮಾಡ್ಕೊಳ್ಳಿ ಬೇಕಾದ್ರೆ. ಇಲ್ಲೇ ಗಮನ ಇಟ್ಟು ಕಲೀರಿ, ತಲೆ ಒಳಗೆ ಹಾಕೋರಿ. ರೈಟ್. Every definition will have two components. One is qualitative, another one is quantitative. Now I have explained what? Qualitative. Now quantitative. See here, strength of electric current. Strength of electric current, we define it quantitatively. What is it? Time rate of flow of net charge steadily through a surface is the strength of the electric current, or simply current. That means now I already explained this. So now you say 10 positive charges are going like this. Hello?
Yes, sir.
10 positive charges are going like this. 5 negative charges are going like this. Hello?
Yes, sir.
What is the net flow of charges? 5 in this direction, plus 5 in this direction. Got it? Got it all of you? Net flow. Now this plus 5 has gone in say 1 second. So plus 5 divided by 1 gives you strength of the electric current. Now this plus 5 charges can go zook like this, or like this, or like this. Current is different. Understand? Current is different. Obviously, you see now, you open the tap, water is slowly coming. Maja barangila. Jor tirgisi. Then you hold it with your finger like this. Then the water starts coming at high velocity. Maja barteti. So the current is more. Understood? But there are two things in it: quantity of the charges and also the rate of flow. So delta Q gives you quantity of charge. Delta T gives you time. They are independent. Understood? I can send 100 charges in 1 second, or I can send 10 charges in 1 second. If I send 100 charges in 1 second, current strength of the current is more. Correct? So strength of the electric current, time rate of flow of net charge Q steadily through a surface is the strength of the electric current, or simply current. Mathematically, I is equal to Q by delta T, where Q already I have defined, net charge. And what is delta T? Okay, delta t is the duration of time during which q flows through the surface steadily. Now the word steadily is important. ಅಂದ್ರೆ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈಗ ಡಸ್ಟರ್ ತಗೋ. ಓಕೆ, ಈಗ ನೋಡಿ ಇದ್ರಾಗ ಚಾರ್ಜಸ್ ಅದಾವ. ಇನ್ನೊಂದು ನೋಡಿ, same amount of charges have gone, probably in same time, but it is not steady. Understood? Understood also the meaning? So car is going steadily. Okay, otherwise it is not steady. Understood all of you? Okay, so here you see all these words are important. Why I am telling you so much, student? See, this basic sentence nalli question kellara NEET olaga. ಇದನ್ನು ಹುಡುಗರು ಕೂಫ್ ಮಾಡ್ಯಾರ, ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಇಲ್ಲೇ ಅನ್ಕೊಂತ. ಬಿಕಾಸ್ ಅವರು ಹಿಂಗೆ ಇದು ಇಸಿ ಹಿಂಗೆ ಕಲೀಲಿಕ್ಕೆ ಎಷ್ಟು ತ್ರಾಸ ಪಡ್ಬೇಕು, ನಾ ಎಷ್ಟು ತ್ರಾಸ ಪಡ್ಬೇಕು, ನೀವು ಎಷ್ಟು ತ್ರಾಸ ಪಡ್ಬೇಕು. ತ್ರಾಸ ಪಡಂಗಿಲ್ಲ. ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಚಾರ್ಜ್ ಅಪಾನ್ ಟೈಮ್ ಬರಲ್ಬಿಟ್ಟ ಅದು. ಫ್ಲೋ ಆಫ್ ಚಾರ್ಜ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್. ಸೊ ಫ್ಲೋ ಆಫ್ ವಾಟ್ ಚಾರ್ಜ್, ಇದ್ರಾಗೂ ಚಾರ್ಜ್ ಅದಾವ, ಫ್ಲೋ ಆಯ್ತು, ಯಾಕೆ ಕರೆಂಟ್ ಇಲ್ಲ? ಹಂಗಲ್ಲ ಅದು. ಈ ಮತ್ತೆ ಹೆಂಗೆ ಅದನ್ನ ಹೇಳಿದ್ವಿ. ಅದನ್ನು ಹಿಂಗೆ ಅದು ಕೇಳ್ಬೋದು ಎಕ್ಸಾಮ್ ಒಳಗೆ. ನೀವು ಹೆಂಗ ಕೇಳಿದ್ರು ನೀವು ಹೇಳಕ್ ಬರ್ಬೇಕು. ಕಲ್ತಿದ್ರೆ ಹೆಂಗಾರ ಕೇಳ್ರಿ ಹೇಳ್ತೀವಿ. ಬರೋಬ್ಬರಿ ಕಲ್ತಿಲ್ಲ ಅಂದ್ರೆ ಯಾವ ಬುಕ್ನಾಗ ಈ ಕ್ವಶನ್ ಕೊಟ್ಟವ್ಲೆ, ಈ ಬುಕ್ನಾಗ ಅಷ್ಟು ಕೊಟ್ಟಕೊಳ್ಳೆ ತುಂಬಿದ್ದು, ನೋಟ್ಸ್ ಬರ್ಕೊಂಡಿದ್ದು, ಕೋಚಿಂಗ್ ಕ್ಲಾಸ್ ಹೋಗಿದ್ದು ಕಡಿ ಚಿತ್ರಾನ್ನ. ಅದ ಎಷ್ಟೋ ಹುಡುಗರು ಸುಮ್ಮನೆ ಕೂತ್ ಮನೆ ಒಳಗೆ NCERT ಬುಕ್ ನಾ ಹೆಂಗೆ ಕಲ್ಸೇನಂಗೆ ಕಲ್ತಾರೆ. ದೇ ಹ್ಯಾವ್ ಗಾಟ್ ವಂಡರ್ಫುಲ್ ರಿಸಲ್ಟ್ಸ್. ಅದನ್ನ ನೀವು ಮಾಡಬೇಕು. ತಿಳಿದಲ್ಲ? ಈಗ ನಾ ಹೆಂಗೆ ಹೇಳಿ ಹಂಗೆ ಇರಬೇಕು. ರೈಟ್. ಸೊ ಮ್ಯಾಥಮೆಟಿಕಲಿ I is equal to q by delta t. I have explained this. Okay. Mr. Murthy? Now, see, in elaborately I have explained. Right? So, NE be the number of negative charge particles, QE such as electrons. So, now always see negative charge andre enpa? It is charged. If a body has got excess number of electrons, it is negative charge. So here when I say QE means, you should say it is a small particle whose charge is QE. That means, as you are told, excess number of electrons are there. Correct. So, and now you don't have to always think about excess electron. I can give you a small thing like this and I say its charge is QE. Electron charge is E. Small e. What is the value of small e? 1.6 into 10 to the power of minus 19 coulombs. So like that, you have got some charged particles whose charge is 3e. ಅಂದ್ರೆ ಹುಟ್ಟಿದಾಗ ಅದರ ಚಾರ್ಜ್ 3 ಇರ್ತದೆ. ನೀವು ಅಲ್ಫಾ ಪಾರ್ಟಿಕಲ್ ಅಂತ ಇರ್ತದೆ ಫಿಸಿಕ್ಸ್ ಒಳಗೆ. ಇಟ್ಸ್ ಚಾರ್ಜ್ ಇಸ್ ಪ್ಲಸ್ 2e. ಅಂದ್ರೆ ಒಂದೇ ಎಂಟಿಟಿ ಇಟ್ಸ್ ಚಾರ್ಜ್ ಇಸ್ plus 2e. Electron charge is minus 1e. ತಿಳಿದಲ್ಲ? It is always in multiples of electrons. Electron charge, that is there. So, yet Ne, small n suffix e be the negative charged particle QE. That means there are any number of QE charges. So, such that electron, the total negative charge QE will be what? Ne into small QE. Understood? What is small ne?
The number of
what is small QE? The charge on each particle. So total charge, if I give one lump, the total charge will be Ne into QE.
Yes.
Are you able to get it? Yes. Bundi undi. Each bundi is QE. Total laddu, number of bundi into this one laddu. That is the laddu. Capital QE.
It's total charge on the
Total each particle is small QE. There are any number of particles. So the total charge becomes Ne into QP. QE. Any doubt you have got here? No doubt. Similarly, positive charge. NP QP. Ladu undi, rava undi. Now, if QE moves through a surface A in time delta t, in a particular direction, say east, then the conventional direction, then the conventional current say IE is towards west. Correct? QE is moving towards east. So the conventional current will be west. QP is moving through the same surface in delta T in the particular direction east, then the conventional current is also east. QE through smooth surface with delta T in particular is west, then the conventional current is east. QP moves east. ಯಾಕಂದ್ರೆ ಅದು ನಿಮ್ಗೆ ಅಷ್ಟು ಎಲಾಬರೇಟ್ ಆಗಿ ಬರ್ತೀನಿ ಅದು ಎರಡೇ ಬೆಟ್ಲೆ ಟೈಪ್ ಮಾಡ್ತೇನೆ ಹಂಗೇನು ಟೈಪಿಂಗ್ ಬರೋಂಗಿಲ್ಲ ನಾವು if QE and QP move through the surface delta T in a particular direction say east, then the conventional current will be algebraic sum of both. Got it?
Yes.
Now QE and QP move through a surface delta T in a particular direction say east, then the conventional current is algebraic sum. Andre you should take the sum with the sign. We'll further note next step. So therefore I will be I suffix P plus minus of I suffix E. Now please understand this. What is this? How did I get this? See, electron current is IE and the positive charge current is IP. But the conventional current will be minus I. Got it? And the conventional current will be plus IP. Got it? What is the total current? Algebraic sum of both. Understood?
Yes.
So therefore I can write it as IP minus I. But actually the original thing is this. Is that clear?
Yes, sir.
So the conventional current IP is same as the current of yes, thank you. Go. Is same as IP. Now the conventional current of electron flow is minus I. Is it clear?
Yes, sir.
No, that is what I have explained. If the algebraic sum yields, if the algebraic sum of these two yields a positive number, then the current is in the direction of IP. If the algebraic sum is negative, then the conventional current is in the opposite direction of IP. If the algebraic sum yields negative number, then the net rate of flow is this. I hope you understood this statement.
Can I explain?
Further, if the algebraic sum of this IP minus IE yields a negative number, then what is the direction of the conventional current? It is in the direction of the flow of ಅರ್ಥ ಮಾಡ್ಕೊರಿ. See, if the algebraic sum of this yields a negative number, okay, if the algebraic sum yields a negative number, then the net rate of flow of electric charge, then the conventional current is in the direction of QE. In whichever direction QE is flowing. Okay, now try, see, now don't confuse yourself. See, what I have done here is, basically, what I have tried to say is, this formula is what I am trying to tell you. See, there are two currents here. One is this current and one is this current. See, now understand, students. See, there are electron is flowing, so the electron current is IE. The positive charges are moving, the positive charge current is IP. What is the conventional current due to IP?
Algebraic.
Plus IP. What is the conventional current due to IE? Minus. Understood? So what are these? See, what are these under the brackets? Conventional numbers. Now, sum total of these conventional currents will give you the total conventional current flowing in the wire. That's what I have told. Now, if this quantity is larger than this quantity, so this, if you now simplify it, you will get it as IP minus IE is equal to I. Now, if this quantity is larger than this, then you will get a positive number. If this quantity is larger than this, then you will get a negative number. So, if this quantity is more than this, then that means the current is in the direction of IP.
So the current or the conventional current?
See, now what see, once I have used the sign and I have written here, now these two are conventional currents. Amma, nodu, bari IP barre idu current due to positive charge. This is current due to negative charge. Now, if I add the sign, then these are conventional currents. Now, I have written this equation. Now, in this equation, this and this are representing the conventional currents. This and this are representing the conventional currents. Is that clear?
Yes.
Now, if this is more, then the conventional current is in the direction of IP. If this is larger, you are getting a negative number. That means, see, now what I am trying to tell, this is a wire. In this wire, I have said the current is I. In this wire, the current is I. In this, both positive and negative charges are flowing. So, this current I will be positive. Means what? The assumed direction is this, and the current is also going in this direction. Got it?
Yes.
Now, that is if this is larger than this. Now, if this is larger than this, I will get a negative number. Which means my assumed direction of current was this, but actually the current is flowing in this direction.
No, assume you don't.
I have assumed the direction current is एक circuit में एक मैंने current लिखा. I have assumed that the current is flowing in this direction. And then I analyze. And then I find out this. See students, I'll tell you. Now you solve problems in optics. Hello?
Yes, sir.
See, now you have said 1 upon u plus 1 upon v plus 1 upon u. Object is in front of the concave mirror. 10 centimeters in front of the concave mirror. So, what will you do? Minus by. And it is concave mirror of focal length 5 centimeters. Right? Then you will say this is also minus. Where is the image? You don't know where is the image. So you have to find out it. But you will not use sign convention there.
Yes, sir. Yes. Yes.
Got it? Hello?
Yes, sir.
But here, if you don't put any sign, it means it is positive sign. Hello?
Yes, sir.
So here, when you are writing V, what is V here? It is an image, but it is plus V. So you have assumed that now, when you write this equation, you have now assumed that the image is behind the mirror.
Yes, sir.
Is it clear?
Yes, sir.
Hello?
Yes, sir.
You have assumed it is behind the mirror,
Yes, sir.
and then you solve this problem. So when you solve this problem, 1 upon V will be equal to 1 upon 10 minus 1 upon 5. That gives you, what will I get? So 5 minus 10, I will get how much? Minus 5 upon 50. Correct? Hello?
Yes, sir.
So I will get here minus 1 upon 10. Correct? No?
Yes, sir.
No? Here.
Minus 1 second.
Now what is V? V is equal to minus 10. So now what is this minus means? See, understand now. जब मैं ये equation लिखा था, according to sign convention, V is behind the concave mirror.
Yes, sir.
Because it is plus. I have assumed when I wrote the equation like this, my assumption is the image is behind, but the answer I got is minus. So my assumption is wrong. The image is not behind, it is in the front. Got it?
Yes, sir.
इसी प्रकार इलेक्ट्रिसिटी में जब आप प्रॉब्लम सॉल्व करोगे तो आपको किसी कारणवशात you have to assume the current direction is conventional current direction is this. ठीक है? तो इसमें क्या होता है? इसमें दो करंट, एक IP है और एक I है. Positive charges are moving in this direction, so IP is positive. Negative charges are moving in this direction. In which direction? See, positive charges are moving in this direction. Negative charges are moving in this direction. So the conventional current is again plus. So you will get a positive number. So your assumed direction is correct. Wait, this you understood?
Yes,
Now next. Now in this wire, you know that the positive charges are moving like this, plus. The negative charges are also moving in that direction. Then you will write it as minus I. Now if you add these two, you are still going to get a positive number. That means the assumed direction of the current was same. It is correct. Now if you get a negative number, that means the assumed direction of current is not this, but it is in this direction. Is that clear?
Yes, sir.
So when you have to deal with positive and negative charges, this issue will be there. This issue will creep up in second year PUC, not in 9th standard and 10th standard. Don't worry. In 9th and 10th standard, you will not have this problem at all. You have only one current, conventional current. Don't worry. You will sail through. But when you come to PUC 2, you have to deal with this. You have to deal with semiconductors. You have to deal with different currents. Then this will be important. At that time, I don't want you to have confusion. That's why I am explaining this. Clear? Yes.
Means actually positive currents don't move, no, sir. It's only like electrons and the ions.
No, ಈಗ ನಾನು ಕಲಿಸ್ಬೇಕಾದ್ರೆ charges move ಅಂತ ಹೇಳಿದ್ರೆ charge, what did I tell? It can be ions and it can be free electrons. Did I not say?
I thought.
So why did you think when I say charge, when I say charge, it means it can be electrons, it can be ions. See, there are other charges other than ions and electrons. There are other charges which you will learn in PUC 2. Now already I have taught enough. I don't want to teach more.
Flow of electric current flows, that means electrons are flowing.
Now, frankly speaking, see, in salt solution will both not flow.
Positive also.
Salt solution, sodium ion and chlorine ion both will move, no?
Yes, sir.
But ಅದನ್ನೆಲ್ಲ ಚಿತ್ರ ತೋರಿಸಿದ ಏನು ಉಪಯೋಗ ಆಗ್ತದೆ ನಿಮಗೆ?
No, sir, but like in if it is about only free electrons.
It is about
free electrons.
see, ini confusion ಮಾಡ್ಕೋಬೇಡ. ಈಗ ನಾ ಇದು ಕಲ್ಸಾಕತ್ತಿದ್ದೆ ನೀನು ಕನ್ಫ್ಯೂಷನ್ ಆದ್ರೆ ನಾ ಇದು ಕಲ್ಸೋದಿಲ್ಲ. ನೋಡ, ಈಗ ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರೋಟಾನ್ ಮಾತಾಡಿದ್ದೇನೆ, ನಾ ಚಾರ್ಜ್ ಮಾಡಿದ್ರೆ ನಾನು ಬರೆದಿದ್ದಕ್ಕೆ ನೀವು ಕೋರಿಲೇಟ್ ಮಾಡಬೇಕು. ಇದ್ರ ಹಿಂದಿನ ಚಿತ್ರ ಏನು ತೋರಿಸಿದೆ ನಾನು ನಿಮ್ಗೆ? ಇದ್ರಾಗ ಏನು ತೋರಿಸಿ? ನಾನು ಇದ್ರಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತ ಎಲ್ಲಿ ಬರ್ದೇನೆ ಹೇಳ? ಐ ಹ್ಯಾವ್ ಟೇಕನ್ ಲೆಟ್ QE ಬಿ ದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಂತ ಬರ್ದೇನಿಲ್ಲ? ಲೆಟ್ QP ಬಿ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂತ ಬರ್ದೇನಿಲ್ಲ? QE means it can be electron also, it can be negative ion also. QP means it can be a positive ion or some other positive charge. Positive charge is bare proton alla. Proton has got positive charge, but proton I am not saying here. It can be any positive charge. It can be any positive charge or any negative charge. Got it? See, this is how I am building the theory, man. So I created a concept called charge. Without need kudi, need permission. ಯಾರು ಆರಾಮಿಲ್ಲ ಅವ್ರಿಗಷ್ಟ ಪರ್ಮಿಷನ್. ರೈಟ್. ಈಗ ಕನ್ಫ್ಯೂಷನ್ ಬೇಡ. ಈಗ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಎರಡು ಫ್ಲೋ ಆಗ್ತಿದ್ದಿಲ್ಲ, ಮುಗಿತು. ಈಗ ಟ್ಯೂಬ್ಲೈಟ್ ಒಳಗೆ ಎರಡು ಫ್ಲೋ ಆಗ್ಲಿಕ್ಕೆ ಪಾಸಿಟಿವ್ ಅಯನ್ ಅಂಡ್ ನೆಗೆಟಿವ್ ಅಯನ್ಸ್ ಆರ್ ಫ್ಲೋಯಿಂಗ್. ದಟ್ ಇಸ್ ವೈ ಯುವರ್ ಟ್ಯೂಬ್ಲೈಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್. ಸೊ ದೇರ್ ಆರ್ ಮೆನಿ ಥಿಂಗ್ಸ್ ಲೈಕ್ ದಟ್. Got it? If they say metal conductor, then only electrons will be free. Tanaka electrons are negative charge ಆಗೋದಿಲ್ಲ. Electron are negative charge ಆಗೋದಿಲ್ಲ, ಮತ್ತೆ ಯಾಕೆ ಅದನ್ನು ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ? In conductor, if electric current is flowing, it is only on account of free electrons. ಮುಗಿತು. ಏನು ಕನ್ಫ್ಯೂಷನ್ ಅದ? ಈಗ ಏನು ಡೌಟ್ ಅದಕ್ಕೆ? ಏನು ಕೇಳ?
like conventional current just like actually ಇರಂಗಿಲ್ಲ ಸರ್, efficiency
ನೀನು ಮಾತಾಡ, ಸ್ಪಷ್ಟ ಮಾತಾಡು. ನಾ ಹೆಂಗ್ ಮಾತಾಡ್ತೇನೆ ಒಂದೊಂದು ವರ್ಡ್ ಮಾತಾಡ.
conventional current actually ಇರ್ತೈತೆ, just calculation purpose ಇದೆ.
ಈ ನೋಡು ದೋಸ್ತ ಇದು ನೋಡ, ಈಗ ಸಪೋಸಿಂಗ್ ನಾನು ರಾಜದೀಪಕ್ಕೆ ಹೊಡೆದ್ಬಿಟ್ಟೆ, ನಿನಗೆ ಬೇಜಾರಾಗ್ತೈತಿಲ್ಲ? ಆಗ್ತೈತಿಲ್ಲ? ಆಗ್ತೈತಿಲ್ಲ? ಸೊ ಹಂಗೆ ಭಾಳಷ್ಟು ಹೈಪೋಥೆಟಿಕಲ್ ಇರ್ತಾವೆ, ಅದಕ್ಕೆ ಕಾರಣ ಹೇಳಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಓಕೆ, ಇರಲಿ. ಇವಾಗ ಕನ್ವೆನ್ಷನಲ್ ಕರೆಂಟ್, ಕನ್ವೆನ್ಷನ್ ಅಂದ್ರೆ ಏನು ಅರ್ಥ? ಕನ್ವೆನ್ಷನ್ ಮೀನ್ಸ್ ವಾಟ್? See, all of us have agreed on one thing. See, my name is Sudheer Murthy. It's a convention, no? So, if all of us are following the same convention, then what is my name? Leah Kattagala, what is my name? You don't say Narsimha is my name. Murthy is not my name. You know, no, because there is a convention followed. First we will tell person's name, then father's name, then surname. Correct, no? Convention, no?
Yes, sir.
Hanga ida. Current is flowing in this conductor. Means it is conventional current. Why the current is flowing? What is the reason current is flowing? It is on account of what? Is it on account of positive charges? Is it on account of negative charges? That is the matter of investigation. So if positive charges are moving, then conventional current and the direction of positive charge are same. If negative charges are moving, then the conventional current is opposite to the negative direction. See, that comes next. First, you will say, you go and get yourself introduced. Then your date of birth, everything they will write. First, they will ask you what is your name. And then they will ask you your date of birth now to find your age. Or first, they will ask you date of birth. Like that. So here, conventional current is this. See, just now I solved a problem in optics. We have used a convention. What is the convention? We are going to do the measurements from the pole of the concave mirror to the object. Pole in the object. So what is the direction of measurement? From pole to the object. Hello? And what is the direction in which the ray is traveling from object to the mirror? In this direction. Therefore, this measurement is negative. Convention. This measurement is negative. Hang banta? Convention. Ardhatala?
Yes, yes.
Got it? Innu confusion is the barkombarni ಕೇಳ್ರಿ 745